Time, it marches on, right? Every second seems the same for everyone, everywhere. But what if I told you that's not entirely true? What if time itself could be stretched and squeezed? That's the mind-bending idea behind time dilation. Imagine two perfectly synchronized clocks. One stays put on Earth. The other takes a trip on a very fast spaceship. When the spaceship returns, the clocks won't match. The clock on the spaceship will show slightly less time has passed. This isn't a clock malfunction, it's a consequence of Einstein's theory of relativity. Time, it turns out, isn't absolute. It's relative, meaning it can flow at different rates depending on how fast you're moving. The faster you move through space, the slower you move through time. It's like the universe is balancing the books. Einstein's theory tells us that space and time are intertwined. They form a single fabric, a cosmic tapestry called space-time. Massive objects like planets and stars create warps in this fabric, much like a bowling ball placed on a trampoline. These warps are what we experience as gravity, and it's gravity that influences the flow of time. The stronger the gravity, the slower time flows. This effect is most noticeable near extremely massive objects like black holes. But time dilation also happens at speeds we can achieve. Astronauts on the International Space Station, for example, age a tiny bit slower than people on Earth because they're moving faster and experiencing slightly weaker gravity. The difference is minuscule but measurable. Time dilation is real, and it has been experimentally confirmed. Here's a thought experiment to help visualize time dilation. Imagine a train traveling at close to the speed of light. Inside, a person shines a flashlight at a mirror on the ceiling. The light bounces back down. To the person on the train, the light travels a short distance up and down. But to someone standing outside watching the train zoom by, the light's path appears much longer. It travels diagonally as it goes up and down, following the train's motion. Remember, the speed of light is constant for everyone. So if the light travels a longer distance for the outside observer, time itself must stretch for that observer to accommodate the constant speed of light. This is time dilation in action. The speed limit, why we can't break the time barrier yet. As we approach the speed of light, time dilation becomes more extreme. If we could somehow reach the speed of light, time would theoretically stop altogether. We would become timeless travelers, frozen in a single moment. But there's a catch, a big one. Nothing with mass can ever reach the speed of light. It would require an infinite amount of energy, which is impossible. It's like nature has set a speed limit for the universe. So, for now, time travel to the future through speed remains in the realm of science fiction. A future of time travel? Even though we haven't cracked the code of time travel, the universe is full of mysteries waiting to be solved. Perhaps there are loopholes in the laws of physics we haven't discovered yet. Maybe wormholes, theoretical tunnels through space-time, could provide shortcuts for time travel. Or perhaps we'll develop technologies that allow us to manipulate gravity and time in ways we can't even imagine yet. One thing is certain: the human thirst for knowledge and exploration will continue to drive us to unravel the secrets of the universe, including the enigma of time. The journey of discovery has just begun.